Okay, so this is addition and subtraction with fractions. The process is exactly the same thing. The only thing that changes at the end is whether or not you add or subtract. If we go in picture form, first of all, if we had this rectangle is a whole shape. We can then split it. I'm going to split it into quarters. If I'm then talking about rectangles, that then means that everything would be exactly the same shape repeated. Each of these quarters would always be the same size. If I wanted to add or subtract anything to that, so for example, if I went for thirds, these sections here on the circle wouldn't fit into the sections there of our rectangle. So what we have to do is make them the same. So bin all this. So if we take, for example, 1/4, add 1/4, this just gives us 2/4, and then we can then think about simplifying. And the reason we can just add these together is because our denominators are the same. Our end product is the same denominator as well. This is exactly the same if we wanted to do subtraction. So say we had 5, 6, and we wanted to subtract 2/6 off of that. We can then just do our numerators, our top numbers. 5 subtract 2 gives us 3/6. And again, if we need to, we can simplify where possible, but we can look at that at a later stage. So whenever our denominators are the same, all you need to do is add or subtract your numerators. But when we get fractions, say for example, let's go 5, 6, subtract 1/4, we've now not got slices of those shapes from before that are the same size. So what we've got to do now is make them the equivalents with the same denominator. So equivalence is like simplifying, but what happens is our numerators and denominators normally get to be bigger numbers. The actual fraction size stays the same. So for example, if I had this shape here and I had a half and I shaded in the half, if I then split it again in half, my green shaded area still stays the same. If I split it again, my green shaded area still stays the same. But what's happened is my slices have got ever so slightly smaller each time, depending on how I've done it. If I was, say, for example, it was a slice of cake and there was a whole cake and I was going to eat half of it, each time, effectively, I'm going to eat half, but I'm taking smaller bites each time. So if we go back to this question again, so 5, 6, subtract 1/4, the first thing we need to do is give the bottoms a little bit of a kiss. Okay, that will give us a common denominator. So we're going to do 6 multiplied by 4, which gives us 24. But whatever you do to the bottom, we've got to do to the top as well. So we then multiply 5 multiplied by the 4, which gives us 20. And then we also need to do then the 6 multiplied by 1 to give us 6. What that does is it keeps 5, 6 the same size now, but it's 20/24. And 1/4 stays the same fraction, but now it's wrote as 6/24. Now we've got the same denominators. All we need to do now is do your subtraction. So your denominator will stay the same. And we then do 20 subtract 6, and that then equals to our 14. At this point, then we can look to simplify, which just means is that we're just going to, instead of we'll still have the same denominator because we've only got one fraction to deal with now, which is the 14 over 24. But to simplify it, we're then looking for a common factor for both. So they're both even. So I'm going to divide them both by 2. So then I've got 7 over 12. Okay, so when the denominators are different, we multiply the bottoms, which is the orange. Then you multiply your diagonals to get your numerators, which is the green parts. Now that we've got two equivalent fractions with the same denominator, we can then just do the subtraction at the top and then the answer at the end. Sometimes needs simplifying, it doesn't always. I'll show you an addition one as well. Addition is exactly the same. So if I did, let's see, let's do 2/5 add 1/6. So again, first thing I need to do is give the bottoms a little bit of attention. I'm going to multiply the bottoms up. 5 multiplied by 6 gives me the 30. I'm now going to do my diagonals to keep them. So I've got 2 multiplied by 6 to give me 12. And then I've got 5 multiplied by 1 to give me 5. I'm addition, so I'm just adding them together. So 12 add 5 gives me 17. My denominator stays the same. And then I've got my final answer. This time that one doesn't simplify, but that is just adding and subtracting fractions.